Well, hey friends, how we doing? All right. So we've talked about how to do the derivative of a natural log. Now we're going to be talking about how do we do the integral of a natural log, or the antiderivative. So just a little review here. We already kind of saw how the derivative of any natural log function. Let's see here. Let's make that f of x here. Woo. We saw how that was equal to the derivative on top and the regular function on the bottom. So we're gonna essentially undo that. Now you need to remember something about a natural log. We can't ever take the log of a negative number. So being that we're also going to eventually evaluate some of these, in order to guarantee that we never get a negative number, we always have to put that f of x in absolute value. Okay, so always make sure you put that absolute value around your x. So that's just our most general basic one. And if we were to add a little bit to it and actually deal with functions here, so we did f yesterday, I'm using g today. That would be the natural log of g of x. Oh, that was an ugly looking x there. There we go. Now, I'm going to throw these at you. And again, you could go through and generate them pretty quick. It's not terribly hard, at least tan and cotangent. But we've already learned a couple of trig integrals already. So we've already learned these two. We've already learned that the integral of cosine is sine. I forgot the x there. There we go. And the integral of sine is negative cosine. Well, natural logs now, they'll allow us to find the integral of the other trig functions. So the other trig functions, here's what they are. First up, we have tangent. And that one is going to be equal to the negative natural log of cosine. And again, we're not going to get too much into how all these things work out, but general rule to think about is, how would you write tangent? Well, it's sine over cosine. And you can kind of see, oh, wait a minute. You can start to kind of see how, if this is in our denominator, the derivative of cosine is negative sine. Well, we're missing the negative here. And you can kind of see how that natural log is going to end up playing itself out a little bit. Okay. Like I said, it's not too terribly bad. I proved them to you in your notes again. So if you want them, they are in the printed notes. But again, as long as you understand the gist of where they're coming from, I don't think you guys necessarily need to see the proof for every single one of them. So the natural log of sine x. And then we have secant. And secant is going to be natural log of secant tangent. So a lot of times when you guys are dealing with the trig ones, it's just a matter of just figuring out and identifying, oh, wait a minute, that's secant. Oh, wait a minute, that's cotangent. And you just plug it into your trig formula function, you'll be good. And then the last one you have, friends, is cosecant. So we only have Oh my goodness, we only have 3 more integrals to get the whole rest of the school year, and then we are done with integrals. Still got a few more derivatives left. I take it back. We have 4 more integrals left. But we still have a few more derivatives left. All right. So these are going to be the big thing that we're dealing with here today. Now, the hard part that we're going to be looking at, so essentially, for the most part, we're going to be dealing with just natural log of functions. We won't do too much with these guys, although they will pop up from time to time, so just be looking for them. But biggest thing to remember is when we're dealing with these, how do you determine whether to use a natural log or a power rule? So for instance, say I have x plus 2, and I have x squared plus 4x plus 4. One of these is a natural log integral, the other one's not. And it all comes down to what's going on in the denominator. Biggest thing to remember here is we look at our denominators. If our denominators can be factored and taken to a power, then it's not going to be, it wouldn't be an integral, or it wouldn't be a natural log. So if you look at this first one, I can't factor that at all. So that's not going to a power. However, if you look at this other one here, this does factor. It comes x plus 2 squared. So notice that can be taken to an exponent. And since that can be raised to a power other than 2, that means I can rewrite it as a negative exponent. And now it's a power rule. So, and we're going to go through and do several of these here. So this one right here, this would have been a log integral. And this one right here, then it would have been a power rule. So as we're going through, you need to remember, not every integral is automatically just going to be a log. Now today, for what we're dealing with here, they will be, but that's not always the case. You got to be careful of what we're actually looking at. Make sure that it actually is a log. So what we're going to do is we're going to do a whole bunch of integrals here. And again, it's going to be one of these drill and kill type of things. So hopefully you got all of these written down here, and we're just going to kind of drill and kill it as we go. Our first one we're looking at here, we got 5 over x plus 2 dx. And let me write a few of these up here. I'll write a few at a time. Let's go x squared, x cubed plus 3 plus 7. And let's try this one here. X minus 1, x squared minus 2x minus 8. So anytime we're looking at these ones that have a denominator, I have to ask myself, can that denominator be written as a power other than to the negative 1? Because that doesn't do anything for me. In this case, this one's pretty easy to tell. It won't. And so since it can't be written as a power, I can go ahead and I can rewrite it then. All right, where I pull that out, and I'm going to be able to go ahead and look at this as a natural log. So we start with, look at the denominator, it's x plus 2, and the derivative of x plus 2 is 1. And that's all we're doing here. And again, you don't have to write this part, but just remember, you're taking your denominator here, and you're asking yourself, what is that in the numerator? In this case, it is. If the derivative or a form of the derivative is in the numerator for the denominator, then this makes it a natural log. I can't factor the two the denominator to some sort of power, so I can't worry about that. So therefore, then I look and say, is my derivative of my denominator in my numerator? And notice, again, I'm putting it in absolute value, because I got to make sure that I guarantee that my natural log is a positive value. X cubed plus 7, well, that doesn't factor, so I can't write that to a power. So this is one of these. If I can't do that, we also want to make sure we remember that we're still going to be using our u substitution. That's not going away. So if I let u be x cubed plus 7, that means du then is 3x squared dx. So one of the ways I can look at this then is I can look at this as 1x cubed plus 7 times x squared dx. So sometimes if I look at my exponent here, the derivative of this bottom was 3x squared. Well, I had an x squared, so I didn't have the full derivative. But by doing a u substitution, I can go ahead and make my natural log show up. So in place of x cubed plus 7, I would have had u. And in place of x squared dx, I have 1/3 du. And you guys can kind of see how the rest of this is going to play out then. 1 over u du. So 1/3 times the natural log of u plus c. And then substitute our x cubed plus 7 back in. So hopefully you guys are kind of seeing how this is going to kind of work out here today. So why don't you guys do me a favor, go ahead and pause the video now and take a shot here at this next one, see what you guys can come up with. All right, let's see how you did. So we're going to set that denominator equal to u. And I see that I have du equals 2x minus 2. So that didn't quite give me what I wanted. So I have my 1 over x squared minus 2x minus 8. Notice the x squared minus 2x minus 8 factors, but it doesn't factor into a something to a single power. Right? I have two separate factors. It's not a repeated factor. I'm going to take my x minus 1 out there. So when I'm looking at this here then, I'm saying, oh, wait a minute here. What if I take a 2 out? Now there I can see my x minus 1 and my dx. So if I factor it over, 1/2 du equals x minus 1 dx. So we go ahead, we do our substitutions here. There's my u, and then I'm going to have a 1/2 du. So in integration, we don't have a lot. It's just the biggest thing we got to always be able to do is recognize what it is that we're currently dealing with. And if we can recognize it, we'll be in okay shape. And the College Board, they love natural logs. You will see these a few times. You just got to make sure you can pick up when they're asking you to do it and what you can do with it. All right, so hopefully we got a little gist of that now. Let's go ahead and play with a few more of these here and let's see what you guys can come up with now. Let's try 3x plus 12. Let's go. How about x squared plus 8x plus 7. I told you guys I was going to drill and kill you today. So, lots of drill and practice, friends. Just stuff that we have to practice. Let's try this one. Can you give you a bunch of different things? This one is one of my personal favorite ones to use on tests in previous years. And let's see here. All right, let's guys go ahead and pause it and see what we can come up with. All righty, well, let's see here. First up, I'm going to take that denominator, set it equal to 0 so I can try to get an idea of what I'm looking at here. du is 2x plus 8 dx. I don't really see myself able to do much with that. So what I'm going to end up doing here is I'm going to go ahead and factor out my 3. See if that kind of opens things up a little bit. And friends, by doing that, my guess is you hopefully are starting to see x plus 4 dx. We actually have that one. I can do some of that. There's my x plus 4 dx. So I can make that differential pop up. So we end up with 3 over 2, 1 over u natural log, or du. So this next one, remember we said whenever we got multiple things that involve u sub, try to take the biggest thing. So if I'm looking at the denominator, usually on a u sub, I make for logarithm, for natural logs, I make u the denominator. Well, I got 2 things in the denominator. I got x and natural log of x. So pick the uglier one. So in this case, I got natural log of x. So that means du is 1x dx. And friends, that right there is not too bad because I have 1 over the natural log of x. I can break this up to being 1 over x dx. So there's my u. Here's my du. Turned out that was my whole differential right there. So this is kind of funny. Natural log of u. Well, if u is the natural log of x, that means I'm taking the natural log of a natural log. Well, With that one under our belt, why don't you guys take a little shot at this one? I think you got a better chance of getting this one now. Sometimes, again, it helps just to rewrite it. So now you can hopefully see the u there. So let's make the u natural log of 3x minus 4. And if we do our du, do our differential, we have 3 over 3x minus 4 dx. And if we divide that 3 to the other side, you get 1/3 du equals 1 over 3x minus 4 dx. And again, there is our differential. For some reason, I am having a hard time getting blue. There we are. So there's our u and 1/3 du. These just take a lot of practice, a lot of different examples. You just need time with it. You guys are definitely able to do it. But it just takes a little bit of time, a little bit of practice, and a lot of repetition. All right, so we're cruising through here, Let's see if I can give you guys a few more here that may be just able to challenge you a little bit more. See if we can't step it up just a little bit here. How about, let's throw in some. Throw in a trig one. We haven't done that yet. I should throw in maybe another trig here. And let's have a little fun with this one here. Whew, all right. Let's pause these and see what we can do with these. All right, let's see how you did here. So first of all, if it were me, I would have broken this one up into two separate. I would have had tan x plus 1. And I've broken this one up into cotangent of x minus 2. Sometimes, again, it just helps to take it into pieces. They're both natural logs, but we can hopefully catch it a little bit easier. So that's going to be the natural log of cosine. Oopsies. Of x plus 1. Plus the natural log of sine x minus 2. Well, the thing that bugs me about this one is I got a 3x in there. So that tells me I probably better you do a u sub again. So then when I do that, I get u equals 3 dx, or du equals 3 dx. Sorry about that. So 1/3 du equals dx. So that means when I substitute everything in there, I get my u. I get my 1/3 du. And it's back to being just a normal, another one of my trig, natural log trig ones. But at least now I can actually see it a little bit easier, and I've dealt with that 3 in the middle. So 1/3 times the natural log of secant u tangent u, secant u plus tangent u, excuse me. And then we plug it back in. So we have a 3x there, and a 3x here. There we go. This next one is a little bit of a weird one. I mean, if you look at it, you can try to put it up and make it a power rule, but then you have a product rule that's going to be used, and we don't have product rules here. This is kind of a different one. So here's my hint for you guys. Let's start off and let u be equal to x minus 1. Go ahead and pause the video and see if you can actually do something with that. All right, let's see what you guys came up with. If I let u be x minus 1, that meant that I had then u squared du. But this x up here is still bugging me. But if you remember what we've done before with that is, if I still have an x left over after a u sub, go back to where you did your u sub and solve it for x. And if I do that, I end up with something looking kind of like this, u plus 1. So it's kind of very similar to what we did before, back when we were dealing with some of the radical ones. And I would go ahead and clean this up a little bit by putting each one of these over u squared. And by doing that, I can see how I'm going to have a 1 over u. So I'm going to have a natural log there. But notice on this one, this is going to be a natural log and a power rule put together, which is kind of cool. So natural log of u, that's the first part. And then the second one, add 1 to my exponent and divide by it. So then natural log of whoop minus whoop to the negative 1 plus c. So we can plug everything back in there. So u was x minus 1, so we can plug that in here, and then a little x minus 1 here. There we go. Let's take a look at one more different-ish type one. And then we'll look at some definite intervals here. Again, in case you haven't figured out, this one is pretty much a whole lot of practice. On a lot of examples, you'll see a bunch of these. X squared minus 5x plus 6 all over x plus 2. All right, think back to integrated 3 and pre-cal on this one, friends. See what you guys can do with that. All righty, so we got a couple little options here. Remember what a fraction bar means. Fraction bar means to divide. So if I wanted to, I could do a little polynomial long division, but friends, I remember how much you guys did not like polynomial long division. So some of you are like going, no thanks, I'm going to avoid that one. That's fine. We don't have to do polynomial long division. We could do our generic rectangle division. That one's fine too. Remember, we had 3 ways to divide. So since I got a feeling some of you would have done it this way, remember this row right here has got to add up to negative 5x. I will go ahead and do it this way as one of my ways. So x plus 2x means that this has to be a minus 7x to make this work out. And then when I bring my negative 7 up here, in order for this to be a positive 6, notice positive 2 times negative 17, that's technically negative 14. So in order for this to be a positive 6, and that means I needed to add 20. So that would be my remainder. So one way to do this is I could have came up with x minus 7 plus 20 over x plus 2. The other way to do it would have been to use everybody's personal favorite, synthetic division. Again, I got a feeling majority of you did not do polynomial long division. You probably went back to one of these old time favorites. So we got 1, negative 2, negative 7, 14, and 20. Remember, we always drop at 1, so that would have been 1x, or x minus 7. That's our remainder over here, plus 20 over x plus 2. And just so remember, the negative 2 there, that came from setting this equal to 0, whatever we're dividing by equal to 0. So either way, friends, I don't know what pre-cal integrated 3 way you would have ended up dividing. Maybe you did polynomial long division. Maybe you did this one up here, polynomial long division. You probably, or maybe you divided with the generic rectangle, or you did synthetic division. Either way, whatever way you did, the biggest thing we want to do is we want to divide it out. So when we divided everything, it would have came into 20 over x plus 2. We go ahead and we just divide it like normal. Now from there, friends, I would have gone ahead and made this 2 derivatives. Our normal one, and then my one that's still left over with a derivative. And since I don't like that 20, I'm going to pull that out real quick before I do all my integration. There we go. And now it makes for, once we've done our polynomial long division, friends, it makes for a very straightforward integral. So 1/2 x squared minus 7x plus 20 times the natural log of x plus 2. So just like the power rule opened up a lot of integrals to us, and we have all our separate trig rules, using this idea here of natural log, we can actually end up doing a lot more with these. So last couple things we need to look at, friends, is what do we do if we are going to evaluate some definite integrals? So we spent a lot of time looking at indefinite. Let's do a brief little bit about definite integrals, and then we will call it. And it's not that it's going to be that much more, but we need to remind ourselves a little bit about the arithmetic, because if this is on the multiple choice portion of the test that's non-calculator, the College Board will do some arithmetic involved that you're going to need to make sure that you know how to clean these things up. So you guys can do that integral there pretty darn quick. I'm not worried about that. But now notice, we keep those absolute values there because sometimes we might end up with a negative value. I'm not going to here, but I might end up with a quote unquote negative value. And we can't evaluate negative log or logs of negative numbers. So this makes sure that we don't. So I end up with the natural log of 3 minus the natural log of 1. So we're not going to see that answer on our multiple choice quiz. It's not going to be an option. We have to remember what natural log of 1 is. It's going to be 0. So our answer was going to end up being just natural log of 3. So we have to make sure, guys, that there's going to be times that we have to evaluate natural logs for these definite integrals, which you guys are going to be just fine at doing, but we have to be okay with the fact that it could happen. So let me give you a couple of these to try, and then we'll call it a day. You're like, we've already done a ton. I know. It's good practice, though. I want to make sure you guys are really solid on natural logs because they are going to show up a ton. A ton, a ton, a ton. All right, go ahead and pause the video and see what you guys can do with these. All right, let's see. U is x squared plus 3. So du is 2x dx. And by the way, I would have broken this up a little bit. Just so I can see the pieces of it. So there's my x dx. So I just got to get rid of the 2 there for my differential. So 1/2 du equals x dx. So here we go. So there's my u, here's my 1/2 du. Now remember, if I'm going to do a u substitution, I got to change my bounds as well. So that means I need to figure out what u of 1 and u of 3 would be. So 1 squared plus 3 would be 4. So this just became 4. And u of 3, that would be 3 squared plus 3, which would make that 12. So we get our 1/2, 4, 12, 1 over u du. So 1/2 natural log of u from 4 to 12. I'm not going to worry about plugging my x expression back in. Well, that's technically should be absolute value, but absolute value positive 12 is positive 12. So natural log of 12 minus natural log of 4. Now, again, you're not going to probably see an answer like this on the multiple choice test. FRQ, I'm done. I'm leaving it alone. But you're probably not going to see an answer like that because what's going to probably happen on the multiple choice, remember, when you're subtracting logs, it's the same, and they have the same base, you're actually dividing the numbers. Chances are you're going to see something that would look like this. 1/2 natural log of 3. And if you're, another thing you might see, you could see this, I don't think you would, you could see natural log of 3 to the 1/2. You can see that. Another thing you could see, if it's 3 to the 1/2, you might end up, you could see the square root of natural log of 3. The biggest thing is you need to be comfortable with your operations on logs because your answer on the multiple choice portion could come up with as one of these different answers. I'm guessing it'd probably come up as 1/2 natural log of 3. So that's what I would expect to happen, but you never know. Just be ready for it. All right, and then our last one here, we have a trig, cotangent. We just learned that one today. That's the natural log of sine. And we have pi over 3 and pi over 4. So when we plug these in here, friends, we get natural log of sine of pi over 3. And the College Board will not allow us to leave this, even on the FRQ part, is sine of pi over 3 and sine of pi over 4. They will always make you evaluate trig values, trig functions. So sine of pi over 3, friends, that would be root 3 over 2. Pi over 4, that would be root 2 over 2. And we can combine these here. So you might get an answer that looks like that. I don't necessarily think you would. My guess is you would get something a little bit more simplified. You might not. If it's the FRQ, again, we are leaving it alone. We are not touching this. Subtraction is the same thing as division. So that means this is the natural log of root 3 over root 2. I could see you getting an answer looking like that. Or, I don't think you would, but we could rationalize that. We could get root 6 over 2. That's always possible, I guess. I don't see that happening. But you just want to, again, you want to be okay with the arithmetic that goes into it, so that way you know some of the different ways you could write that answer. So just be aware. You guys will do great. You'll be fine. So, all righty. I'll see you in the morning. We'll talk more about this.